All right, so today is 21st, the Friday, last day of the week. Another third week is gone. Wow. Anyway, hopefully we go back to school in the next 1 or 2 weeks. So we're going to still discuss roots of quadratic equation. If you were taking additional mathematics or further mathematics, these are some of the things that you'll be doing. What area of what's about the roots that we want to discuss? Without solving an equation, we want to be able to find the nature of roots. Basically, these are all without solving. Find the nature of roots. And the other one, we want to be able to use some symmetric properties of root. That's what we call them, properties of roots, to solve problems. Okay, so these are the major ideas for today. So what do we mean by nature of roots? So let's alpha and beta be the roots of a quadratic equation. Ax squared, sorry. It's not necessarily monic. Okay. If alpha and beta are the roots of this equation, then they can be and beta can either be equal, distinct, doesn't matter how to spell distinct. Distinct means different. Or complex roots. Okay. These are the three natures. So if someone asks, what are the natures of roots? Equal, distinct, or complex. Those are the three natures. The first two means the roots are real numbers. Real numbers can be positive, negative, fraction, decimal, square root, blah, blah, blah. Okay? So those are real roots. So is either the root is real or the root is complex. If the root is real, then it crosses the axis, x-axis. If the root is complex, then it doesn't cross it. Do you remember this during some of the investigation that we did in IGCSE syllabus? Does everybody remember some of this idea of crossing and not crossing?
Yeah.
All right. So we are now putting extra work into understanding this. That's what we're trying to do. Okay. So when is it equal? When is it complex? And when is it distinct? Let's consider the quadratic formula. Okay, we all know that I would say recall because it's something you know. For ax squared plus bx plus c is equal to 0, we know that we can find the roots by a formula b minus b plus or minus the root of b squared minus 4ac everything all over 2a. I believe everybody remember this. So this is our quadratic formula, so we know that. This is what determines what the root looks like. Okay, this is what determines it. How is that? If this, now you have, let's say for example, x equals minus 1 plus or minus square root of something, we don't know, divided by 2, for example. If this is 0, what do you notice? You have 1 plus 0, 1 minus 0. Does it make any difference? Talk to me, guys.
No.
No. So if this is 0, 1 minus 1 plus 0, minus 1 minus 0 doesn't make any difference, which means when this is 0, the two values of x are what?
Equal.
Are equal. So that is why we're going to have the equal roots when what you have under the bracket is 0. I'm coming, I'll tell you the name later. Now, if this is more than 0, maybe 0.1, okay, we can always find the square root of 0.1. What happens when you do minus 1 plus that square root and when you do minus 1 minus that square root? Would they be equal or different?
It will be different.
So
It'll be different.
When this is more than 0, okay, when this value here is more than 0, you're going to have different values, different answers. Does it make sense? Now, if this is less than 0, so maybe minus 1 under the square root, then your calculator gives you error, okay? Square root of minus 1. So you can see that. And you see square root of minus 1, okay? And if I check, you get an error. So that's what happens when you have a complex. You're trying to find the square root of a negative number. Okay, I'll show you again. Trying to find the square root of minus 1, and I get an error message. So if you have something less than 0, you get an error. And that means you're actually dealing with complex roots. It's not really an error if you put your calculator in complex mode. So basically, if you press mode, okay, if you press mode, this, you're going to see COMP complex. So that's 1. So you're going to press 1. So now I should have it in complex mode. No, that's not complex, sorry. Complex is 2. Complex is 2. Okay, can you see that? Complex is 2. So if we press 2, at the top of the screen, can you see complex? So now if I find the square root of a negative number, square root of minus 1, so watch what the answer will be. Did you see that? What can you see?
Y. What? 1.
No, it's like an I,
It's I.
like the letter I. Yeah.
Wait, it's a little blurry.
Just press on your own calculator. Maybe
It's
it'll
the letter
be
I.
easier to see.
Just press your own calculator, like they said. Can you see that?
Yeah.
Okay. So that's because we are in complex. Okay. Complex number is something you will be talking about next year. So basically, if you have negative, you'll be dealing with complex roots, the roots in form of I. Okay, but we're not going to worry about that now. So you can see that this expression under the square root is what discriminates between them, right? Because it's telling you, oh, you guys are equal, oh, you guys are different, you guys are complex. So we call this expression the discriminant, okay? The discriminant. So the expression, so I'm going to write the expression D equals, I just use D to represent it, B. Okay, this expression determines if the roots, I'll just say determines the nature of the roots. Okay, so we don't write too much. Determines the nature of the roots. Okay, so D equals that. It's called the discriminants. It's called the discriminants. Discriminants of the equation. Okay, so it's the discriminant, the guy that discriminates, the guy that tells them, oh, you guys are equal, oh, you guys are, the guy that classifies them, the guys that put them into nature. He doesn't see all the nature as the same. So these ones are equal, these ones are complex, these ones are these things. So that dude is called the discriminant. Okay, so this is where we're going. Now, the nature of roots, how does this help us? We have seen it in my previous explanation, particularly when we made use of the calculator. Trying to see. Okay. So in summary now, the roots of ax squared, so this is actually what we need, okay, 1 equal if D, just call it D instead of D squared minus 4ac. If D equals 0, distinct if D is greater than 0, complex if D is less than 0. Basically, these two, the first two, is when roots are real. Okay? Because if it is not complex, then it is real. Understood, everyone?
Yes.
Yes.
So that is okay. Someone is sending a message. All right. Okay. If your mic is not working, please feel free to leave a message. If your mic is working, please talk to the mic. All right. So have you taken note of that? May I move to the next board? You know, this discriminant can also be used to check if you can factorize a quadratic expression. I'll give you an example. Look at x squared minus 5x plus 6. That is x minus 2, x minus 3. Yes?
Yeah.
Yeah.
Also, 4x squared will be plus 4x plus 1. This will be 2x plus 1, 2x plus 1. Okay, now let's find the discriminant in this. Can somebody find the discriminant for this expression and the discriminant
one.
for this expression?
The first one is 1.
The discriminant is 1?
Yeah.
Okay, yes, that's correct. What about second one?
0.
Is equal to 0. Okay, let's check this. What's the discriminant here?
81.
81. So D is 81. Last one. What's the discriminant here?
Positive 25.
We have only one person in the class. Positive 25.
I'm a little confused. Sorry.
What is confusing? Speak now.
Can you like explain what one of the answers? I'm just like a little bit lost.
Lost about. I want to know what you are lost about so we know what to explain.
How you got the discriminant?
Giselle, I want to know what exactly your question is.
I'm not exactly sure. Like for the first one, like I'm still trying to understand like the discriminant, like the.
What
like
is discriminant? Do you know what discriminant is? Giselle, do you know what discriminant is?
It's the b squared minus 4ac. It's the part that like.
All right, so
like,
b squared minus 4ac for this question. What is the value of b squared minus 4ac for the first question? What is b, Giselle?
-5.
What is a?
1.
What is c?
Minus a 6 to 6.
So can you calculate b squared minus 4ac yourself?
Yeah.
Can you calculate that and tell me what the first one is? I'm waiting.
1.
1. All right, so check the last one also to understand what it did. I hope Giselle knows I'm waiting for her to respond.
25.
You should always say something. When I pause like that, it means I'm waiting for you to respond. You don't wait for me to say something before you respond, please. And that goes to everybody. We're just going to keep wasting each other's time here. All right, so everybody understand how to find discriminant. So my question is, all these expressions can be factorized. What is the relationship between the fact that they can be factorized and what the discriminant is? What is the condition for you to say, oh, you can factorize an expression if the discriminant is something? Give me a condition just like this nature of roots. The root will be equal if the discriminant is 0, distinct if it is greater than 0, complex if the discriminant is less than 0. So I want to write something similar. An expression can be factorized if what happens to the discriminant?
If the discriminant is a square number?
Exactly. If the discriminant is a square number. Who said that? Whose voice was that?
Kelly.
Okay. So if the discriminant, can everybody see that? This is 1, 0, 81, 25. So if your discriminant is a square number, and that makes sense. It means under the square root, an integer can be obtained, isn't it? If this is a square number, then you are assured of an integer. So if you do minus b plus an integer, maybe m, divided by maybe q, then you are rest assured that this will give you a fraction or a whole number, which means you can actually factorize if you had factorized earlier. Does this make sense?
Yes.
This makes sense.
That makes sense, yeah.
Okay.
Could you say that again? I didn't really understand it.
Okay, I'm trying to guess where this. I'm trying to monitor its sound, but I think it's clear now. Or is it my sound? All right.
I can still kind of hear the sound, the buzzing sound at the
Yeah, so I
background.
don't know where that is coming from. Okay.
It might be someone else opening their mic.
Okay, maybe everybody should turn off their mic until you want to say something, please. Okay, I think that's better now. I think it's Elson because it stops now. Elson, you want to check your speaker because it doesn't give us that last week. So if you are trying to find maybe x equals minus b plus or minus square root of blah, blah, blah over 2a. If you can factorize, you can either get, if you can factorize an expression, it means when you solve the equation, you will get an integer. Yes? If you factorize this, and if you can factorize this, it means when you solve this equation, factorize is only for the expression. Solving the equation is when you have equals to 0. That's an equation. Does that make sense to everybody? If you can factorize an expression, it means you can solve the equation by factorization. If you factorize this, it means when you solve this equation, let me put it here. If you can factorize x squared minus 5x plus 6, it means you can solve x squared minus 5x plus 6 is equal to 0 by factorization. If this can be factorized, then this can be solved by factorization. Does that make sense? Now, if you factorize, you get x minus 2, x minus 3. It means when you solve this, you're going to be getting integers 2 and 3. Similarly, if you can factorize that, it means you can solve that by factorization. And when you solve it, you get this. So anytime you can factorize, you have two possibilities. You get either an integer or you get a rational number. Okay? And that can only happen if in this formula, under the square root, you can have a square number. Because remember, these are not decimals that cannot, even if you write it in decimal, you can always express it back in fraction. But in this case, if you have like 5, for example, square root of 5 is not a decimal you can write in a fraction form. So this whole thing cannot be a fraction. So you can only get a fraction if an integer comes out of this square root. So when an integer comes out of this square root, minus b plus that integer divided by 2a can either be a whole number or a fraction. Does that make sense, Elson?
Yeah, it does. Thank you.
So that's why we say that we can solve by factorization, or we can factorize if this discriminant gives a square number. So that's what Kelly is trying to talk about. Now, so let's put it down with, so this is another way of using discriminants. Let's write it again, like in addition to the other ones. I wish this eraser can be bigger so I don't have to go through every pixel screen. All right, so here we are. Let's just put it down properly. So remember, we said the roots can be this and this and that also. So I'm going to say also d equals b squared minus 4ac can be used to determine if ax squared plus bx plus c equals to 0 can be solved by factorization. To solve it by factorization means that is, if ax squared plus bx plus c, can somebody complete that? Can, yes?
Can be factorized.
Can be factorized. Okay? Factorized. If you can solve the equation by factorization, it means you can factorize the expression. Okay, that's two different things. It means you can factorize the expression. Okay. So when does this happen? This is only possible if or when is a square number. I write it in full. So whenever you want to check if you can solve by factorization, and you're finding it difficult to get the factors, quickly check for the discriminants. If you check for discriminants and a discriminant does not give you a square number, then it means you're wasting your time trying to figure out the factors that do not exist. Am I making sense? It means you're just wasting time trying to figure out the factors that do not exist. So this condition is a good technique to determine if you can go through the factorization route. So the moment you get a quadratic equation to solve, remember, the question may not say solve by factorization. You really want to decide if you want to use factorization. So the moment you get the quadratic equation to solve, you can quickly check what is discriminant. If you do not get a square number, just go straight to the formula method. So don't waste your time trying to figure out, oh, I'm going to multiply this by this. Okay, everyone? So this is another way in which we can use the discriminants. Okay, so let's see some examples. So I will write examples and I will ask you to begin to solve them. Okay. Find K. Oh, no. Let's begin with find the nature of the roots. Find the nature of the root of these equations. Uh-oh. Does everybody know what to do?
Yes.
All right.
Kind of, yeah.
Kind of. Giselle, find the nature. Find the nature means determine if the roots are equal, distinct, or complex. Okay?
Okay.
All right. Let's make attempts, then I will solve them if you are not able to.
Mr. Daniel, can you go back a page? I forgot what it's called.
Okay.
Just real fast, just like a second. Right, yes, thank you.
You want to take a picture so you don't delete the class?
Yes, thank you. I have.
All right.
Do we need to tell you when we're done?
Yes, please.
Okay, I'm finished.
So is code equal? What is this statement?
All right. So the first one, what did you get? Anybody?
Complex.
Complex roots. All right. So basically, this is the workings. Identify your ABC. Then work out D equals B squared minus 4AC. So I'll be getting 3 squared minus 4, 1, 4. So that is 9 minus 16, which is negative 7. And that is less than 0. So let's say, therefore, the roots are complex. Or therefore, the equation has complex roots. Similarly, A is 4, B is negative 1, C is negative 5. And you work out D equals B squared minus 4AC. B squared is minus 1 squared. You can see that, put that in brackets. 4AC is 4, 4, negative 5. So that will be 1 plus 80. Right? Which is 81. And because that is greater than 0, therefore, the roots are real. Include real, please. Real and distinct. Does that make sense? What about the third one? What do you get for the third one?
Equal.
Equal. Thank you,
I
Justin.
got equal.
Real and equal. All right. Include the word real. Does that make sense, everyone?
Yes.
Real and equal. So this is the official solution that is acceptable. Whenever I ask you to do such a problem, so please take notes. This is what must be done. Okay? So the next set of tasks that I want you to do, so maybe I write that as 2. Determine whether or not this can be factorized. A. Should I say determine whether or not this can be factorized and why? So, and why? Why do you say that? A. B. No, let's say 5x squared minus x minus 6. B. 3x squared plus 4x plus 5. Determine whether or not this can be factorized and why. I need you to try that. Are you done? Do you have questions? Or you just need more time?
Need a little more time.
All
I
right.
need a little bit more time.
Okay, no problem. Justin down, okay, got it. Have you taken note of the question? Because I want to put something else on the board and I need to change to the next page.
I'm done too.
All right, so if you need to write something from the board, please take it.
I'm done too.
Okay, so,
Done.
all right. If anybody has question, please speak. If you do not speak, I assume you know. So which means when I give you a test online, you get confused. So do not wait for someone to ask question on your behalf. That is not a good thing to do, because some people will be quiet because they think, oh, well, I'm not the only one who doesn't understand. Somebody will ask on my behalf. And what if nobody asks on your behalf? So you need to learn to speak. So if you have questions, please speak. Do not wait. Uh-oh, we have an empty part here. If you are done, please say something. I can see your comments in the box already. If you have not left any message, please put your message there so I know you are done with the work. Okay, thank you. Sonia, yes. Melody, yes. Okay, good. All right, seems everybody is done. So let's check. So again, to determine if you can factorize, if I'm putting equals to 0 here, then my instruction will be determine whether or not this equation can be solved by factorization. Does that make sense? So to solve by factorization means you can factorize the expression. Now, to determine if this can be factorized, let's see. We're going to just look at what the discriminant is. So A is 5, B is -1, and C is -6. So the discriminant, B squared minus 4AC. You should write the B squared minus 4AC, I told you, times that number. If you write your formula all the time, then you can retain it in your memory. Because some of you, I know, are lazy to write. So this is going to be 1 plus 120, which is 121. Okay? So what is your reason? Can this be factorized? Yes. So your conclusion will be, yes, it can be factorized since D is a perfect square. It's a square number. Yes, we can factorize, or yes, it can be factorized since D is a square number. So I won't be doing the second one, so you can always use this idea. Yes, it can be we can factorize, not can be factorized. Yes, we can factorize because D is a square number. Is this how we did it? If your reason is different, please tell me what your reason is so we can determine if your reason is valid or not. Is this everybody's reason?
Yes.
Is this everybody's reason, please?
Yes.
All right.
Yes.
Yes.
Okay, so we're good. So the next question I want
Yes.
to give you, I need you to start. It's still on the application of what we have discussed today. You need to think very well. That would be question 3, all right? Question 3. Yeah. Okay. This is good enough. Okay, good. Question 3 says, find the possible values of K. K is a number, okay? If the roots of x squared minus k plus 2x plus 4 equal to 0 are equal. That's the next question.
I'm done.
That was fast. Okay. Done, done, done. Okay. Put the people down. Four. All right. With Mr. Iron Man is 5. So let's give others some time. Okay, good. Let's see how many done do we have. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. About 10, no, 11, 12, 12. If you're still working, can you put in the chat, I need more time, or I need 1 minute, I'm almost done, something like that. Any time, okay? We'll give you 2 more minutes. Almost done, all right. The rest of us, please check your work to be sure that some more time, okay? And we can do the correction. Remember, these are examples, they're not graded work. The work to be done will be posted later in the day or tomorrow. And I'll set the due date for, I don't know, if I can set it within a few hours, I'll put a due date for Sunday evening. If I can't set it today, if I set it on Saturday, I'll put a due date for Monday evening. So even after Monday's class, you can continue to complete the work. But it won't be too much work. It will be on the nature of root, factorization, condition, and this type of problems. Even the next thing I'm about to discuss with you briefly will not be, should I even discuss the next thing? Has everyone turned in the quiz? Let's see. If I still have one person not turn it in, then I can't do the next thing because it might be used as a cheat. Okay, then I still have one more person. All right, so I haven't, there's one more person that hasn't turned in the quiz. So maybe the nature of rule that I want to do, let's see. I can give you something to try. I can ask you to try something before next time. We'll just forget about the second objective. Don't worry, we'll look at that on Monday. All right, so after this correction, I'll let you go. We won't talk about the second objective now. Okay, Anika done, no, Elsin done now. Justin done. Anika and Joey, I'm waiting for you guys. What is yes? Okay, better. All right. Okay. So, can I ask? I'm going to call a name. Is Shirley here? Is your mic working? I'm waiting for her to respond. I'm sure she heard me. You don't think so? It's a yes or no question, not a maybe question. My mic is working, my mic is not working. All you have to do is unmute yourself and speak to the computer, and I'll tell you if I can hear you or not. In fact, you should be able to hear yourself. So can you unmute yourself and speak to the computer so we know? Then you can confirm if it is working or not.
Is it working?
So I guess it's working. All right. So can you tell me the first thing that I need to observe in this question? You have done it, right? Can you walk us through what you did? Come on.
Like b square minus 4ac equals to 0.
Let b squared minus 4 is equals to 0. That's good. But before then, you have to do something. Before this, we have to do something before this. Anika, she's right, but what is the first thing to do before this?
I just wrote the question down.
Anika, can you speak up?
X squared minus k plus 2x plus 4. I wrote that first.
What?
I wrote the question down first.
The question you don't need to write. Melody, what is the first thing before this? Elson, put your hands down. If I need you, I'll call you. Thank you.
Identify the ABC.
Thank you so much, Melody. Identify the ABC. A is 1. B is what? Melody.
B is minus bracket K plus 2x.
Good.
Bracket X.
Very good. And C is 4. So this is the first thing. Thank you, Melody. I like that. Identify A, B, and C. So once you identify A, B, and C, then you can write this. I hope you all know that rather than working with this, I could actually say this means B squared equals 4AC. Yes?
Yeah.
So this could be a formula you will use in this type of problem. Okay? So now, then we can substitute. B squared means minus, B squared means minus of this. I could open the bracket, minus K plus 2, and write it as minus K minus 2, then I square the bracket. I could do that, okay? And I could decide not to. So maybe we can look at the workings in 2 ways. Then you pick whichever one works for you. All right. So if I do not open the bracket, then I can say minus K plus 2 all squared for 414. Is that right, everyone? So what happens when you do minus 5 squared? What do you get?
25.
Do you know it is minus squared, 5 squared, like that? Minus is squared and 5 is squared. Do you all agree? Talk to me, class.
Yes.
Yes. So which means I could write this as just K plus 2 squared. Yes? What did you do after this point, Justin? Justin?
I'm not sure if it's right, but
Just try. Try me.
I didn't do it, but I think now what you're supposed to do is square root 16.
But what did you do? Did you expand the bracket?
Yeah.
Yeah, that's also allowed, but it's just a longer process. But what you just said now is the faster one, okay? So you could do K plus 2, you find the square root of the other side, and it will be in plus or minus form, okay? So which means K plus 2 is plus or minus 4. So K, not X. So K will be negative 2. We did completing the square some times ago, yes?
Yes.
And we remember this approach. When you take this to the other side, this is the first one you write. You remember this kind of workings? Then you can split into 2. K equals negative 2 plus 4, or K equals negative 2 minus 4. So K could be 2, or K could be negative 6. What Justin was saying earlier is that if you do not use this approach, from here you could expand K squared plus 4K plus 4 equals 16. So K squared plus 4K minus 12 equals 0. Then you go factors of 12, that gives 4. That's 2 and 6. So that will be negative 2 and positive 6. then either k minus 2 is 0 or k plus 6 is 0. Justin, is this what you were talking about?
Yes.
So that's also allowed. Okay, so I write this clearly. So this is plus 4k. Okay, so you see the two values of k are that. And if you do not want to use this approach, so when you identify your a to be 1, b to be negative k plus 2, you may open the bracket immediately. Okay, and your c is still 4. So you could say b squared minus 4ac equals to 0. Okay, I say from this, it implies, this symbol means it implies, okay? Means it leads to, okay? It implies that b squared equals 4ac. So you could come here and do minus k minus 2 squared equals 414. So minus k minus 2 squared equals 16. And you solve exactly, either you solve this way or you solve this way. This is my preferred approach. As long as you have a square number here. In some problems, you could have k in middle and k here also. In that case, if I have like 16k, I have no choice but to use this method because I have to expand and collect the like terms. But if this is a number, this is a better way. Does this make sense, everyone? Talk to me, please.
Yes.
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 So if you got this, let me know. Put in the comments in the group chat. You got it. Something like I got it. I got the answer. Blah 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 blah. I just want to know. If you did not, please. I hope you understand now. You can just write, oh, I didn't get it, but now I understand what to do. Now you understand. Justin, but you said you got it. You just use another method. That's fine. I mean, either of the two methods, either the one in green or the one in black, both are absolutely right. Okay? The only thing is this is faster. The green one is faster. But the black one is a generalization. By generalization, I mean if I give you a problem like 3x squared minus maybe kx plus 7k equals 0. In that case, you can't use this because you end up getting, b squared, which is k squared, okay, is equal to 4ac. 12 times 7 is 84k, something like that. You end up getting this. In this case, you cannot use the method. If this was maybe k plus 1, okay, so this will have to be k plus 1 squared. Okay, to solve k plus 1 squared equals 84k, this method cannot be used. You can only use this method. Is that understood, Justin? So that's why I said you got it, all right? So you just use a different method for the different situation, which is also allowed. So I would say the method in black is more general. More general in the sense that it works for the case of square number on the right and when you do not have a square number on the right. This works for all. But when you have a case of square number, this is a faster approach. Why this is not recommended is that after you expand, you have to factorize again. So imagine if this was 3k plus 2 all squared in the bracket equals maybe 16. You're going to expand this first, you bring this over, then you have to start thinking of the factors again. For example, you expand, you get 9k squared plus 12k plus 4. Then you have to bring this over, minus 16 is 0. So you get 9k squared plus 12k, then minus 12 equals to 0. Then you have to start thinking of the factors. Okay? Can I also say that when you get to this point, check if you can still reduce the equation before you proceed. In this case, I can reduce the equation by dividing by what?
3.
3. So I'm going to have to worry about 3k squared plus 4k minus 4 equals to 0. So imagine how long this might take me. Not like it's going to take long, but you know, you can actually save time. Factors of 12, that gives 4. You have to think of 6 and 2 again. You have to be able to factorize using the method we did last time, and that will take longer time. So as soon as you see that you have a square number only on the right, just take the square root. Okay, that's it. But if you forget to use that method and you use this, nothing is wrong. You are absolutely right. You are only spending extra time compared to the others. If there are no questions, so expect maybe few problems online to be done and turned in latest by Sunday evening or Monday evening, depending on when I upload them online. When we come next time, we'll be looking at this, properties of roots. And these properties of roots, it's depending on the nature, the two, what's it called? The two roots of the equation. Okay, in particular, we will derive something for the sum of the roots, the product of the roots. What happens when you square this, each of the roots? That's why we call it symmetric. Symmetric means what happens to this happens to that. We'll be looking at what happens to this without solving the equation. So for example, I give you 3x squared plus 5x plus 7, which is not even solvable by factorization, okay? And yet, I do not want to see decimal. I don't want you to tell me alpha is 0.7, blah, 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 beta is, we don't want all that. And yet, I want to find this, okay? Or I want you to tell me what is alpha squared beta plus beta squared alpha, okay? Or alpha beta squared. Okay? We want to play around with this root in the symmetric form without knowing them individually, okay? And we can do that by, first of all, establishing what is alpha plus beta, what is alpha beta, and trying to get some expressions for square and cube. I will only talk about square expression, cube expression, and the difference expression, just these 3, okay? So we'll be looking at deriving these 5 next time, okay? In terms of these 2. We derive these 3 in terms of these 2 next time. But the moment I start this, it will be like a cheat to solving some of the questions that I gave you in the quiz. And I still have one person yet to submit the quiz. So we will stop here today, all right? So that's why I thought the last person will have submitted before the end of the class. The person who could not turn it in earlier, who was concerned about leaving me a message and disturbing my peace, had already done it, even while we're in the class, while the other person is yet to. So we're going to give the last student extra time, and it's going to be locked later today, I think in a few hours' time. So that will be the first thing on Monday. Any question from anyone? Please go through the notes from the beginning. Remember, the nature of the root is just to determine which category it belongs, and the discriminant helps us to do that. The discriminant also helps us to determine if you can factorize or not. Look at the examples, look at the detailed solution, and this is an application of that condition, okay? And this is where we stop today. Any questions, please?
No questions.
So, in the absence of no question, I'll be posting the video later. I'm going to start converting once I stop the meeting. I'll see you all on Monday. Have a great weekend.
Goodbye.
Thank you. Bye-bye.
Thank you. Bye-bye.